So this is my lab 7 op amps, and I'm going to be starting with exercise 1. We are asked to solve and derive the gain of the non-inverting amplifier circuit, and we know that gain is equal to V out over Vin, and if we do a KCL node A, we get that gain is equal to 1 plus R2 over R1. So for exercise 2, our setup, we've got our second pin going to A1, that's our inverting, and then we've got our non-inverting one, and that's the white one, going to A0 over here, and then we've got black one being grounded, and we've got this blue one, that's our output, being hooked up to A2. We've got our power, and we've also got this connection from the inverting amplifier to the output, and we wanted our non-inverting to be hooked up to our potentiometer to be able to control, and that's the setup. For the code for my exercise 2, we've got our V in, V minus, and V out all set up and defined at the top, and we've got our serial monitor set up, and we're going to be printing out the analog reads with a value 0 to 1023 for the V in, V minus, and V out, and putting this on a loop, and it's going to plot the data every 50 milliseconds. Now for the processing part, so basically it's a similar setup to lab 5, so if you have any concerns with these lines, please see lab 5 of how we set that up. And the only thing we really changed was adding a couple ellipses and changing the colors and bring that out, as well as we have 3 types of data that we're taking in from Arduino, so we need to change the length of that, add a couple of variables, and change the colors. And so these are printing out these ellipses that are coming in from Arduino code. Now if we run it, we can see the values. And I did make the ellipse for the green and the blue a little bit different because those actually are overlapping, which should be the case because the out and the V minus should be the same as to how we defined our amplifier. And you'll notice that when it goes below 2 volts, the V minus and V out do not follow, they stay at 2 volts. And this is because there's not enough negative feedback from the op amp. So we have, for exercise 3, our setup right here. So first off, we needed to knock the voltage V plus to 2.5, so we achieved that by doing the voltage dividers here. And that's hooked up to our non-inverting amplifier. And then we also have, for the potentiometer, we have a resistor hooked up to here, and which is connected to pin 2. And another thing that we've had to change for this circuit is we also wanted a resistor going into the output here, knocking that resistance down. So that's our setup. Now if we run that, then what we see is this. Now you'll notice the gain of 10 is shown by the ratio of V out to V in. We also have V plus showing the full scale range of the op amp, and we can see that it inverts it when we go up and below down here. You can see the inverting of V in and V out. So this is for exercise 4, integrating amplifier. So what we've changed in our circuit, we've added the capacitor, that's the 10 microfarads capacitor, and the 4.7 kilo ohm resistor. We've replaced that with those resistors we had previously. And again, for the code, we didn't change anything for the code. The only thing that we changed from 2 to 3 and 3 to 4 stays the same is that we have an A4, and that's the third value coming in from, that is the third pin there. So again, that's the only thing we're changing in this code. We're just adding these lines here. And so when we go to run it, so if we look at our processing and run that, we see that as we change the value of V out and increase it, V in is going to integrate towards a more negative value, and then it's going to do just the opposite if we change it for V in. Now for the integration, as you can see, this is a simple integration for exercise 4. We are deriving the output for V out.